Hi, I'm Serhii from Tech, and today I want to talk about the distributed tracing in .NET Core. I'm system architect. Our system is distributed, and tracing is a very important part of it. Why should we talk about it? Why it's so important? Let's start from observability. Observability is one of abilities that should be provided in every system. Basically, it's one of architectural properties of the system. And basically, it says that we should be able to observe the internal state of the system by its external outputs. We cannot get inside our system, we cannot get inside our process. The only thing we can do is just observe some external things, and observability is just about it. Observability consists of three major pillars. These are logs, metrics, and traces. Logs and metrics are familiar to everyone. I guess every developer at least once in his or her life, or maybe twice, or maybe a lot of times, created logs. Sometimes they read them, someone records some performance counters, some metrics, and builds some graphs and trying to understand the behavior patterns of the system, some peaks, maybe anomalies, and so on. And these concepts are familiar to them. But what about traces? Traces is all about distributed stuff. On this slide you can read the definition what trace is. I highlighted with yellow most important things. And most important is that it's about distributed events in distributed systems. And until recently, distributed systems for most of .NET developers was nothing specific, because we were working and we were developing our big monoliths. So usually it was just one service rather than big machine, maybe not so big, but it is still it was one service. It could store its logs into a file or maybe a database. It could expose performance counters using Windows Perf-Mon, and we could find all activities for the service in these logs. Just make an RDP connection to the server, open the file, and after some Ctrl F stuff, you could find anything. However, in microservice world, things are behaving completely differently, because one request might span multiple different processes, multiple different machines, and we need a way to figure out what processes were participating in this request and how much time each of them contributed to the overall timeline. That's why we need a tool that allows us to do that. And there are many different tools. Some of them are provided by cloud providers, some of them are offered by different vendors, and some of them are open sourced. Starting from cloud providers, I think everyone has its own offering. For example, for Azure it's App Insights, for Google Cloud it's TechDriver, Kalinets has X-Ray, and so on. All these have similar functionality, they're very easy to use. Basically they're just key-term solution. You need some package. If it's talking about .NET, this will be a NuGet. You add it, you copy-paste some simple code, and that's all. After that you can see all metrics, all traces, all logs, everything. about your application services on the cloud providers portal. Very easy, very cool. Next in our list are vendors who are offering similar solutions to cloud providers, but they usually are more powerful and they are more well, you can use them from more places, because if we are talking about cloud providers, then usually this offering can be used from inside the cloud. However, for solutions provided by Datadog, New Relic, Elastic, APM, Splunk, sometimes you have an option to host them on your data center and use it internally without need to export your data outside of your organization. Or you can run your services in different places, on premises, on any cloud, and have a single dashboard provided by the vendors. Integration story is the same as above. You have some simple setup code that you need to copy paste, and after that you will have everything out of the box. The next in our list are offerings by open source community that originated with big companies like Google, and two major players are Zipkin and Jaeger. Both are providing rich toolset. They have SDKs for all major languages, and they actually don't require vendor lock, because you can run your own instance of either of them, either Zipkin or Jaeger, on premises or in cloud or whatever. There are ready to use Docker images. And I personally find this alternative more attractive because you can apply it in high variety of projects. So you probably don't need to pay huge money to vendor. They're completely free. You can just install them and use. The only drawback is that each of them has its own SDK, and if you are application developer, you need to make a choice which one you would like to use, because if you change your mind later, you would need to rewrite the code, the integration code, because they have completely different APIs. However, recently all major market players on this area decided to join the efforts and started an initiative named OpenTelemetry. And OpenTelemetry is going to become a single way of working with observability in cloud native world. So the idea of OpenTelemetry is to provide a unified API and the ability to connect to various systems. And in terms of Zipkin and Jaeger, OpenTelemetry provides a unified way when you can connect either Zipkin or Jaeger as a plugin, or even you can connect vendor things like Datadog, Splunk, and so on. So OpenTelemetry currently is the most promising thing that now is in beta phase, but it's been developed very quickly. It's been backed up by cloud native foundation, and I hope that in very near future it will become the only way of working with distributed tracing. Okay, let's move to some terms that we will be using in this talk, in our demo. So when we are speaking about distributed tracing, we are using things like span and trace. Span is basically some operation. It has some name It has a timestamp of start and finish, so you can track how long it took and when it began and when it ended. It has some attributes with arbitrary data that you can then search through in tools like Jaeger and Zipkin and Splunk, for instance. It might have a link to the parent, because span may produce other spans, or if it's a root span, then it of course will not have any parents, but also can have links to other spans that somehow are related to it. Trace, on the other hand, is a combination of spans where one span is a root and other spans were originated in scope of this one span. So on this picture you can see that we have a span A as a root. It has two children, span B and span C. Each of them has small children and so on. So this whole set of spans represent one trace. The same trace could be reviewed from the viewpoint of time. We can see that span A is the longest one because it includes the lifetime of all subsequent spans, and we can see that span A contains span B and span C as children because they are children, and then span B produce span D and span C produce span E and span F. Both are its children. And distributed tracing tools, they provide the SNU for visualizing the traces. OpenTelemetry is a very promising project. It has SDKs for different languages, but the most interesting part for us is of course .NET. OpenTelemetry.NET some time ago entered the beta phase. It's not production ready yet, but it's in beta and it's moving very, very fast. So far it supports out of the box ASP.NET and ASP.NET Core. It supports both HTTP and gRPC clients, Redis client and SQL client, and more clients will come. Unfortunately, it doesn't support yet message bus thing like Kafka or RabbitMQ. However, it should be added in the near future, so if needed, one can implement it themselves, because OpenTelemetry is open source. It has SDK, and adding new providers is very straightforward. Okay, so let's go to demo and see it in action. For our demo, I prepared some code. Let's start from the hello world stuff. The hello world stuff is basically just a hello world example from the original GitHub repository of OpenTelemetry.NET. You can go there and follow instructions and get the same results that we will see right now. Okay, let's see the code. Okay, program. So the code is the following. First of all, we have activity source. Activity source is a thing that produces activities. OpenTelemetry.NET chosen approach not to introduce custom things for spans, but to reuse existing stuff in .NET. It's a system diagnostic activity. so it has been there for some time, and right now it might be familiar to some of the .NET developers, and now you can just reuse it. So activity source is a thing that produces activities. An activity in .NET SDK is basically a span in OpenTelemetry. So first of all, we prepare the activity source. It will produce activity, and then we create the activity, trace provider, where we add in some source. We add in some exporter. Exporter basically is a thing that receives this activity and is doing something with them. Console, for example, you just bring them to console. If you want to send activity to Zipkin, you would use Zipkin exporter, and so on. So every target system will have its own exporter, and if you want to connect it to your application, you just need to add this exporter. Each exporter is in a separate NuGet. So in our case, we will see that we have only one NuGet. It's OpenTelemetry exporter console. We add this NuGet. It will add the transient dependencies, OpenTelemetry itself, and maybe some other stuff. And you can see that currently version is beta, so we need to explicitly set it when you're using command .NET add package, because otherwise it will not install, because it's not it's just pre-release version. Okay, let's get back to the code. So we create the trace provider, and then we just create an activities using our activity source. So we are saying start activity, we wrap it into the using block, should be disposed at the end. We set some text, some arbitrary information. In this case, we set some number, some string, and some array. And that's it. So once this activity is generated, it will be picked up by our exporter and processed. In this case, it will just print it to console. One important thing here is that activity might be null. Why? Because in tracing there is a concept of sampling. Usually we don't want every operation to be sent to our exporter. In high load scenarios, it might impact our performance very badly. We might have high latency and very poor situation with our performance, and usually sampling is applied. Sampling is saying which fraction of all requests should be processed by the exporter, and usually this number is very low. We might want to proceed maybe 1% only, or even less of events. And if sampling is active, then activity will not be created, just not to take the resources. That's why you always need to check it for now, and if it's null, then do nothing. Okay, let's run the code. I will run it using console. So we have this hello and net run. Let's see what will be printed. Yeah, we have activity ID, parent ID is set to something, but it's a root activity. Display name, start time, duration, and our text. We have number, we have string, and we have array. This is how it works in the basics, so you can create activity. And I forget to mention that ASP.NET at least 3 has distributed tracing built in, so you don't need even to install anything. Like, you don't need OpenTelemetry, you can have it out of the box, and you can use it in scenarios, for example, when you have a web API application that is invoking other web API application using HTTP client, and in this case the distributed span will be propagated. You just need to enable it, set some static field, and it will be handled automatically. However, in this case it will be available only via logs, but if you need to connect things like Zipkin or Jaeger, you would need to use either the SDKs or OpenTelemetry for this. Okay, this is our example number 1. Example number 2 is more complicated. It will include 2 services. One will be calling another one, and we will see the results in Jaeger. This is very interesting. Let's move on. So I need to remember it's demo Jaeger. Okay, so this one. So we have 2 services. One is backend and other is frontend. Let's start from backend. So it's just regular web API application. It was created by .NET New Web API. I just haven't removed users and all that stuff. Let's move to our C# watch file to see what nuggets we are using. First of all, we're using exporter Jaeger because we would like to see how our traces are looking in Jaeger. Next thing would be extensions hosting and instrumentation ASP.NET Core. Extension hosting is used to inject our OpenTelemetry stuff into our web API application, and instrumentation ASP.NET Core is used to catch the context of the transaction. So, for example, when our service is invoked by some client, then this package will inspect incoming headers for any trace information, will create appropriate parent span, and will include spans that originate inside the request, link them to this parent one. So it's basically about handling incoming connections. Okay, and that's all for backend, just regular stuff. Or maybe not. Sorry, I didn't show you the most important thing. The most interesting one is startup. How OpenTelemetry is actually being configured. So in configure services, we are adding at OpenTelemetry tracing. We are setting sampler always on sampler. This is a sampler that is used mostly for debug. Remember, I told you that sampling is about removing unwanted traces and spans from being sent to the exporters, and always on, saying that every span should be sent. Otherwise, we would need to make hundreds of requests maybe to get a few results in Jaeger if we remove this line. But with this line, every request will be sent, so we can debug it. Then we add ASP.NET Core instrumentation. As I said, it's about processing of a common request, and also it adds some metadata related to ASP.NET, like verb, like user agent, and so on. And we are adding Jaeger exporter, telling it what service name should be used for this span. So in Jaeger, the service will be named backend. Well, because of backend. And I guess that's all. The only change I made, I removed use HTTPS redirect, just because I want to use only HTTP. And that's all. Okay, let's run it. So we have backend, and we run make it .NET run. Okay, it should be running on localhost 500, not 500 but 5000, and we can check it. Doesn't work because it's our weather forecast, and now it works. So this is just a regular service. But now it will report stuff to Jaeger if we have it running. But let's create a full picture. For a full picture, we need also a front-end service. Front-end is almost the same as a backend, but it has one difference, that in our weather forecast controller we don't have any logic of generating this forecast. We can compare it to backend controller. Here we have our random generator weather forecast, but here we have just HTTP client that will invoke our backend service that is running using this URL, and will just return whatever it sends back to the client. So it acts like a proxy. And also, sorry, I just messed up with my keys. If we front-end start up, it has the same initialization code for OpenTelemetry. The only difference is that we have service name set to front-end, because obviously it's a front-end. Okay, let's run it. I will create another pane. We'll switch to front-end folder, and we'll say .NET run, and I will get an error because port is in use. I need to use another port, and because our ASP.NET Core is so cool, I can do it by providing the port in the command line arguments. So I don't need to change the code or change the app settings config, whatever. I can just run .NET run and provide the URL, and voila, we got our service running on localhost 5555. We can check it, and we see that it works. In logs we see that some requests have been sent. Okay, it is received. Things are going well. Okay, so what about Jaeger? How can we see it in action. To see it in action, I will use Docker image, because I don't want to install it on my machine. It might need some dependencies, maybe Java, maybe Go, maybe whatever. Docker is very convenient way of running it. So I have a Docker command. Like this. So I copy-pasted this command from Google. I just googled run Jaeger Docker and found this command. I executed this command before, that's why it is stored in my history, and I'm using some smart tools that searching through my history for last year or something. That's why I don't need to remember anything. I don't need to write these scripts on the notepad and then copy paste it. I'm just looking through the history and I can run these commands in a matter of seconds. So what we got here? We have the Docker command, we have this Jaeger tracing all-in-one Docker image, and we have some port mappings that should be used. So we are interested in this one. This port actually is the port of UI, local host. Yes, we got Jaeger. It doesn't have any services now. Let's try to do something. It might not work right now. Oh, it works. We have a front end. We can click find traces, and here we go. So we got some trace that contains of two spans. This blue, or whatever color it is definitely not red. It's very close to blue. It's a span of front end, so it started at 0 and its duration is 7 milliseconds. And inside of this span there is a child of it. It's actually a backend, because inside the front end we made a request to a backend, and its duration is 3 milliseconds. So we see when it started, how long did it take. If we click on it, we will find different tags. So we see the host, method, and all the stuff, URL, user agent, and so on. This whole stuff was populated by the package ASP.NET Instrumentation. And the same thing for the backend. For some reason we don't have a user agent, but I think this is because we are using HTTP client that by default doesn't set this user agent stuff. But yeah, we just got the distributed tracing running on a single machine, but in different processes, and it got reported to Jaeger. We can use all this cool UI to look through it. We have some warnings, but this is related to local installation or whatever, because if I click F5, you will have 2 warnings, 3 warnings, so it's not related. Well, I like to think that it's not related to the demo, and this is an unwanted side effect. Okay, so it works. Let's see another demo where we will add some additional text to our trace, and to see it in action let's change the code that runs our application to .NET Watch Run, and here as well. The difference is, as you might know, is that Watch actually watches the files, and when I change any of CS file, it will be excuse me, it will be reloaded automatically. I can show it, like I edit a line and we can see that the code got rebuilt and restarted. But what we need to actually see is so we have demo Jagger processor. Okay, we need to reset our menu. So we will open our backend. We will go to startup, and we will see some new stuff added. And the new stuff is so-called processor. So what the processor is, it's a thing similar to middleware in ASP.NET Core. So we can go to definition, I guess. Yes. And yeah, we have on start and on end. It will be invoked for every activity. And for example, on start we will set some custom tag with some value. And for on end we will get the HTTP response, investigate whether it was success or not, and set appropriate flag in another tag. So nothing fancy. Let's see how it works. Again, we will make some invocations. Then we will go to Jaeger, find some traces, take the last one, open backend, seems to be backend, and we can see my custom tag is set and my custom success is set as well. So this thing allows you to set some arbitrary data that later you can search. So for example, I'm not sure if it will find something or not. Let's try. Operation tags. Oh, we need to explicitly define my custom tag. Oh. And traces. Like this. And do this. No. Okay, so it doesn't work because service should be backend, but after that, yeah, it can be found. We can find traces. So we can think about scenario when we put, for example, some user ID or transaction ID or whatever, and we can find all traces related to this particular user, maybe request ID and so on. Cool! I was able to show the power of the theme. So again, you need to write as little code as vendor solution are. You can integrate with existing tools like Jaeger and Zipkin, and also we will be able to integrate with vendor stuff, with Datadog and so on, because they are actively participating in this journey. They are contributing to the OpenTelemetry, and in near future we will use OpenTelemetry to talk to all distributed tracing providers. I hope it was useful. Thank you very much and have a good conference.